Okay, the next part is we have to find out the relation between average velocity of a body and the time t as shown in the graph. If during the time interval consider the body did not change direction of motion, draw a graph between instantaneous velocity of the body and the time. Average velocity versus time. We have to calculate the instantaneous velocity versus time graph. That should be plotted. Okay, I think we have to, in an accelerated motion, in general, like this much is information is available. Okay, we'll do one thing. I will go back to some basics here. Like in accelerated motion, an object will move. So it is having initial velocity u. After some time, it will acquire a velocity. So this is t equals 0. This is time. So here the velocity, we write it as v equal to u plus at. What is the average velocity for this? For this motion? Already we have discussed. Once again, I'm just. So this should become u plus at dt by t. Solving this. Finally, we'll end up this as u plus at by 2. So this is an expression for average velocity as a function of time. So let's break up this problem for the time interval t2. The average velocity as a function of time. What is the slope of this 2? If you compare this, what in place of acceleration, what should be there? We have to compare here. So in place of acceleration, we have a 4. Try to correlate. So therefore, for 0 to 1 second, the body is going to describe uniform accelerated motion with an acceleration comparing equations 1 and 2. We'll get acceleration as 4 meters per second square. Then what was the initial velocity? Will be 0. Can we calculate now the instantaneous velocity? V instantaneous should be equal to u plus at, 0 plus 40. So this should be the curve for t 1 second to 0 seconds. For the interval of time 0 to 1 seconds, the curve will be of this nature. It will increase linearly with the time. Then the average velocity remains constant. If average velocity remains constant, means the acceleration must be 0. I'll do one thing. Everything, let me bring it at one place. Yeah. What all we discuss for t equal to 1 second. Okay, that's for interval 0 to 1 second. So for interval 0 to 1 second, we have this much of our data. And I'll shade it. So we can plot the graph in the end. Let's analyze the motion. Next, for 1 to 2 seconds, 1 to 2 seconds, average velocity constant. So then what should the instant velocity? Should remain constant as the body moves with a constant speed. If the object moves with a constant speed, then only the instant velocity will remain. Sorry, if a body moves with a uniform velocity, then average velocity, instant velocity will be same. So next, for the interval t, average velocity is 2 meters per second. So therefore, the instantaneous velocity also should be 2 meters per second. The last, we have to analyze this part of the curve. First, we'll write the equation of motion for 4 to 2 seconds. This is one discussion. Everything is becoming green. Yeah. On the last part of the interval, we have to discuss the motion for 2 to 4 seconds. Now, what can be the interval? We have to write equations of motion for it. So V average, let's write it here, t less than V average should be equal to 1 plus t by 2. Here, this part, put t equal to 0, so that the intercept should be 1. It will become equal to 1. Put t equal to 2. The average velocity will be 2. The intercept for this. So actually it will come and intersect here. Then put t equal to 4, the average velocity. Put t equal to 4, the average velocity should be 3. Here the 3 is missing. I'll indicate. So you have to extend this curve like this. But it is defined only for, it is defined only for 2 to 4 seconds. Put t equal to 2, the velocity should be 2. Average velocity. Put t equal to 4, it should be 3. Okay, I think satisfying this. Don't go for this one. It has to be this one. So if you extend back, the intercept will be 1. And what is the slope of this? The slope of this is in fact how much? 1 by 2. You may get in confusion. I'll write it in this way. Oh, no. Slope is 1 by 2. Intercept is 1. Okay, I have this average velocity in hand. So what equation, if you assume, so that what equation of initial velocity you assume, so that the average velocity will be a function of time of this nature. We have to make a reverse guess of thing. So I'll start with, let initial velocity, let it be 1 plus 2. Let me cross check. Okay, this will be t plus t square by 2 by t. Okay, I think I made a guess. You have to guess it and calculate an average value, then it should satisfy this equation. Okay, now we are in a better position to plot the equivalent graph. Let me bring that graph. let's we have to plot the equivalent graph looking at those equations. Instance velocity, everything. So that the curve will be first, it will be a straight line. According to this, it will be a straight line. For 0 to 1 second, it will be a straight line. Then 1 to 2 seconds, it will move with a constant speed. Okay, I'll explain it. Let me put it in order, then I'll explain it everything. I have other colors. Let me pick up this. So this will be the 4 meters per second. So this will be 4. This time should be 1, 2, and this is 4, as usual. Compared to that, the 3 will come somewhere here. So this will be maximum, this will be 5, and it will move with uniform velocity with 2 meters per second. Okay, look at now. So these are the, like if they give curve, no, so we can use this method to plot equivalent graphs. This is a very good question. You have this average velocity. From the average velocity, you are plotting instantaneous velocity. Okay, you may encounter numericals of these kind also. The last one. 1 by v versus 1 by f. The graph represents motion of particle moving along the post axis. Find the average speed of the particle during the time interval in which